In 7.4, make sure that you read the section. It's got some definitions that you'll want to be familiar with dealing with probability. But let's look at number 1A. It says a six-sided die is rolled once. Find the probability of rolling a 4. So we know that out of the 6 sides, only one of them is represented with a 4. So there's a probability of 1 out of 6 that you would roll a 4. 1B, a six-sided die is rolled once. Find the probability of rolling a number less than 20. So the probability of rolling one less than 20, if you think about the numbers on a die, 1, 2, 3, 4, 5, and 6 are all less than 20. So 6 out of the 6 options, which would be 1, and 1 would mean always. 1C, you're dealt one card from a standard 52 card deck. Find the probability of being dealt a club. So the probability that it would be a club, how many clubs are there in a deck of cards? So we know that there are 4 suits, and if you look at the top of your learning guide, you would see how the cards are arranged if you're not familiar with a deck of cards. But the club is one suit, and each suit has 13 cards in it. So there'd be 13 clubs out of the total of 52. And remember that 52, it's nice to remember that 52 is divisible by 2, because 2 times 26 would give you 52. It's also divisible by 13. It's divisible by 4. Since 13 times 4 is 52, that may help you in your simplifying. So if I know that the numerator and denominator are both divisible by 13, that would give me 1/4, since I can cancel out a 13. And that makes sense too, since 1/4 of your deck would be clubs out of the 4 suits. Okay. 1D, you're dealt one card from a standard 52 card deck. Find the probability of being dealt a picture card. So the probability that we have a picture card, think about how many picture cards there are. Picture cards would be Jack, Queen, and King out of your 4 different suits. So that would be 12 in all out of 52. Now remember that the numerator and denominator, we're looking to see 52 is divisible by 2, 13, and 4. So we know that these are both even, but they're also both divisible by 4. So if I cancel a 4 from the numerator and denominator, I'm left with 3/13. So the probability would be 3/13. In 2.A, use the table to find the probability expressed as a decimal rounded to the nearest hundredth. The randomly selected American who moved was an owner. So what I've done here to make it more feasible for us to come up with the correct answer, look at the previous problem, how they actually had total columns. So I've done the same thing here, and I've completed just by adding the total who moved to the same state, total who moved to a different state, total who moved to a different country, and then also calculated the total owners, total renters, and then the totals of both of those columns. So we have a complete total, and if you add them up from both directions, you should end up with this 39. So 39 vertically, 39 horizontally. So we're dealing with 39 Americans who moved. What I want is the probability of that an owner moved. So out of the total people who moved, which was 39, the total number of owners was 14.8. And then in your calculator, 14.8 divided by 39 is 0.37948, and it continues on. So we're going to round that to the nearest hundredth, which will go up 1 to 0.038. 2B, use the table to find the probability expressed as a decimal rounded to the nearest hundredth that a randomly selected American moved was a person who moved to the same state. This is the same chart that we had above. So we know that we had, I'm going to actually copy these real quick. This was our 30.4, 7.3, 1.3, And remember that we had a complete total of 39. I could copy these as well, but I think we've got all the information that we need here. Okay, so the question was probability that an American who moved was a person who moved within the same state. So the probability that someone moved within the same state out of the total number of people who moved, here's our total, 30.4, divide, and we'll get, rounding to the nearest hundredth, 0.78.